Hey guys, this is video 10.6. We're going to be talking about gas stoichiometry. So this is applying stoichiometry now to gases. So it's kind of a review, and there's a couple big things that we'll talk about how this differs from molar mass determination and ideal gas law. So these two, and then the big difference off the bat, these two, 10.4 and 10.5, these are when you're not at STP, is when you have to use those. Gas stoichiometry is when if you're at STP, it makes your work a little bit easier. Now, let's say you forget this, okay? If you forget that, when you have STP conditions, you forget that you can just do a simple conversion, 3-4 step conversion like we did with stoichiometry. You can always use the ideal gas law. You can always use D equals PM over RT, okay, using those pieces. But if you can recognize it, hey, it can save yourself some time. So either way will get you to the same answer. So I just want to kind of, again, point things out to equip you that if you see something like this on the Regents exam, which I don't think you probably will, but just to be there, just kind of give you those extra tools. So gas stoichiometry, we have talked already in depth. We had a whole unit dealing with stoichiometry a while ago where we had our mole roadmap. This is kind of actually going back to unit 3. And then we still use that within stoichiometry. So here's our mass, here's our particles. So we're thinking back to our mole roadmap here. Right? If I want to go from mass to moles, I divide by my molar mass. If I want to go from moles to particles, I multiply by Avogadro's number, 6.02 times 10 to the 23rd. And we can do the opposite here, go back, divide, same number. And we can also go from moles to mass using molar mass as well. We've done these, we've used them. You might feel confident, you might feel confused, whatever. There's actually a third way we can go, but why we didn't talk about that up until this point is because it's only for gases, okay? And that's dealing with volume. Same idea. If you're going backwards, you're dividing. Excuse me. If you're going outwards, you're multiplying. And the number we're going to multiply by here, guys, is that molar volume standard, 22.4 liters. Okay? The caveat here is that it's only at STP. So if you're not at STP, you cannot use that number of 22.4 liters. Okay, so that's going to be the big thing I want to highlight. I want you guys to be aware of. Okay, any gas at STP. This is going along with Avogadro's hypothesis, and they've done calculations to figure out the volume that is associated with that, which is 22.4 liters. Doesn't matter what gas it is at STP, it's going to have that same volume. Okay, so our conversion factor would look like this: 1 mole per 22.4 liters, or vice versa, 22.4 liters per mole. Okay, but again, the key is only at STP. So look in your problems. Hey, do I have STP? Because if I do, I might be able to use this. Maybe, excuse me, maybe I can't. So let's jump into an example. Sulfur dioxide at STP. Right away, we know STP, so we can use 22.4 liters if we're dealing with volume, which we are. We have 98 milliliters. Now, the key that you've got to remember, though, is look at your units. This is milliliters. We can't have, one unit of one thing and then another unit of another thing. So we got to make sure that they are the same. And then also sulfur dioxide. We need mass is what we're looking for. Okay, so we've got to know what the formula is for sulfur dioxide. This is why naming is so important. Sulfur dioxide is 2, so there we go. So we have starting with 98 milliliters. And this is where, guys, if you have mastered that dimensional analysis, it's going to make life a whole lot easier. If I want to go from milliliters to liters, you should know this conversion factor. If not, look on your reference table on the very first page, table, oh boy, I got to find it. Table C. It's got all your metric prefixes. So remember, you put a 1 with the prefix. This is 10 to the minus third. Okay, 10 to the minus third liters. Milliliters are gone. Now we're going to continue on. We are right here. Okay, this is where we're starting. Okay, up on our roadmap, we're starting where the orange star is. We need to go to moles first, then we can go to mass. Okay, so to do that, again, let your units drive your math. So liters goes on the bottom, moles goes on the top. Well, in 1 mole, how many liters do we have? 22.4. Liters are gone. I still don't want to stop with moles. I need to get to mass. So moles here and grams up there. 1 mole. Now we need to have our molar mass. When you add 2 oxygen atoms plus a sulfur, you should get a molar mass that is about 64.07 grams. And at this point, guys, all you have to do then is do the math. When you do that, top times top times top, divide by bottom, you should get 0.28 grams of sulfur dioxide. So my hope is that you can see, hey, this is like one new idea, and the only new piece here is this conversion factor. That was the link we were missing before, and then recognizing, hey, it has to be at STP, but if I'm at STP, that's all I need to do. Yes, I could have used PV equals nRT, because I have my temperature conditions, I have my pressure conditions, R I know, and then I could solve for N, because I had my volume, okay? But this way is actually a little bit quicker, but if you feel more comfortable using PV equals nRT, again, you can do that as well. So I want you guys to try this problem here on your own, and then come back and check the answer out. All right, so mass again is what I'm looking for. I have my volume. Oh, look, I'm at STP, so that means 22.4 liters per mole is in play. So I'm going to kind of do the same thing. 1.33 times 10 to the 4th milliliters. I'm going to set up a T-chart because I'm at STP. I can use 22.4 liters. So I need to get from milliliters to liters. So milliliters on the bottom, liters on the top. Mils will cancel out. I always put a 1 with my prefix, and then I'll put the 10 factor with my base unit. So this is 10 to the minus third. Moving on. Liters on the bottom, moles on the top. 1 mole, 22.4 liters. Moles now cancel out. Grams on the top. Oxygen. Now this is where people may get things wrong. Notice it's O2. Guys, this is a simple piece that we've been doing since Unit 3. So since quarter 1, you've got to make sure that you include all of your subscripts. 2 times 16, my molar mass is 32 grams. When I do all that math, my final answer should be about 19 grams of oxygen. Okay? Now, with that, with our value of molar volume, okay, at STP, we can also attribute that to, or use that when we're calculating density. So again, you can still use D equals PM over RT whether you're at STP or not. So if you're comfortable with that and you want to just remember one thing, great. But if you can make that connection, that again, if I'm at STP, I can use that new conversion factor, molar mass divided by molar volume. So here we go. D equals molar mass over molar volume because I'm at STP. If I wasn't at STP, I'd have to use D equals PM over RT. But since I'm at STP, I can just do this. So CO2, molar mass when you add 2 oxygens together plus 1 carbon is about 44 grams per mole. And then my molar volume is 22.4 liters per mole. Notice, guys, moles are going to cancel out, so we're left with grams over liters, which is a good density unit. 44 divided by 22.4, you're going to get about 1.96 for your density. Okay, so this is just a new take, kind of recognizing a new piece of things we've already done. So try this last one on your own, then you can come back for the answer. All right, now we're looking for molar mass. Okay, we are given density of 1.56 grams per liter. I'm at STP, so that means my volume is going to be 22.4 liters per mole. And I'm looking for mass. Now, one thing I've noticed as I've been walking around, guys, is that people are having issues with fractions. Okay, you've got to practice this. If you're struggling, call me over. We can talk about it together. To clear this fraction, I would multiply both sides by V. Those cancel out there, so M equals V times D. Excuse me, now I just plug and chug. 22.4 liters per mole multiplied by my density of 1.56 grams over liters. Oh, look, liters are going to cancel out. I'm left with a unit that is grams over moles, which, hey, I'm looking for molar mass. That's a good unit for it. When I do the multiplication, my final answer should be 34.9 grams per mole. Okay, so this is the last kind of new piece. Again, it's building off of things we've already learned previously in the course. at this point, now you've got practice to do. This practice 4 is using what we just did, gas stoichiometry, and then practice number 5 is kind of mixing anything together to help you prepare for that advanced quiz, and then that'll be it. So do your practice, don't skip it. Ask questions when you need help. I'll be checking on you. Until next time, see you later.